Here we have a SAT math question. Okay, let's go with the information. So there is a figure given over here. If the slope of line M in the xy plane above is 1/3, what is the area of quadrilateral OECD? So here we have a quadrilateral OECD. We have to find the area of this quadrilateral. Since this line segment CD is perpendicular to x-axis, we can split up the quadrilateral OECD into a rectangle and right triangle by drawing a line segment over here. So now let me mark A over here. So OEAD is a rectangle and EAC is a right triangle because we have a right angle over here. So now to get the area of this quadrilateral OECD, I have to find the area of this right triangle and area of the rectangle over here. So I can get the area of this rectangle OEAD easily because I know that the length of OD is 12 because the x coordinate over here is 12 and the length of this line segment here is 5 units because here the point is 0, 5, the y coordinate over here is 5, then the length of this segment is 5. That is the length of the rectangle is 12 units and the width of the rectangle is 5 units. Then the area of the rectangle is going to be length times width, that is 12 times 5. Then I'm getting 60 square units as the area of the rectangle. Okay, now my aim is to get the area of this right triangle EAC. So for that, what I'm going to do is I'm going to consider the rise and run of the line M over here. So for this line M, OE represents a run and this CA or AC represents a rise. So AC represents the rise and EA represents run. So rise over run. So this gives the slope of the line M. But already the slope of line M is given over here, that is 1/3. Since this AC over EA, that is rise over run represents a slope, it must be equal to the slope of the line M given in the question, that is 1/3. Now we can write the fraction on the left side, the fraction on the right side as a ratio. That is AC to EA equals to 1 to 3. So this number 1 is corresponding to the length of the line segment AC and this number is corresponding to the length of the line segment EA. So whenever I want to get the original quantities from the terms of the ratio, that is if I want to get the length of the line segment AC, the length of the line segment EA from the terms of the ratio, what I have to do is I have to multiply both the terms of the ratio by the same non-zero number, say x. So then the length of AC equals to, we have to multiply the first term of the ratio by the non-zero number, say x, 1 times x is x. The length of the line segment EA equals to, so I have to multiply the second term of the ratio by the same non-zero number. Then when I multiply 3 by x, I'm getting 3x. So this 3x is the length of EA and this x is the length of AC. Okay, so here already we know that OEAD is a rectangle. Since it is a rectangle, opposite sides are equal in length. Since the length of the side OD is 12, the length of EA also must be 12. But here we got the length of EA as 3x. So we know that 3x equals to 12 from the diagram. So let's solve for x in this one. So for that we have to divide both sides by 3. So when I do so, I'm getting x equals to 12 divided by 3 is 4. Okay, now I got the length of AC. So already we have we got the length of AC as x, but now I got the value of x, that is 4. So now I got the length of AC. So the length of AC is 4 and the length of EA is 12. So this EA represents the base of the triangle. This AC represents the height of the triangle. So to get the area of this triangle, what is the formula? So area of a triangle EAC equals to base times height divided by 2. So the base of the triangle is given by EA, its length is 12, and the height of the triangle is given by CA, its length is 4 divided by 2. So 2 goes into 2 1 times, 2 goes into 4 2 times. 2 times 12 is 24. So the area of this right triangle EAC is 24 square units. So to get the area of this quadrilateral OECD, what I have to do is I have to add the area of the rectangle over here and the area of the right triangle over here. Okay, now let me write the required stuff. Here I have written the stuff, that is area of quadrilateral OECD equals to area of rectangle OEAD positive area of right triangle EAC. Already we got the area of rectangle OEAD, that is 60 square units. Let me plug in 60 for this area of rectangle. positive. So we got the area of the right triangle EAC, that is 24 square units. Let me plug in 24 for the area of right triangle. So when I add them, I'm getting 84. So therefore, area of quadrilateral OECD is 84 square units.